Welcome to Trikana Skill, your lifetime career partner. Trikana is a pioneer and trailblazer in the field of civil engineering and construction training, seeking to bridge the gap between engineering studies and the construction industry. Field density test of soil by sand replacement method. Objective: determine the in situ density of natural or compacted soils using sand pouring cylinders. Need and scope: the in situ density of natural soil is needed for the determination of bearing capacity of soils, for the purpose of stability analysis of slopes, for the determination of pressures on underlying strata, for the calculation of settlement and the design of underground structures. Field density: the density, or more precisely, the volumetric mass density, of a substance is its mass per unit volume. Apparatus required for conducting the test: sand pouring cylinder, calibrating can, metal tray with a central hole, dry sand, passing through 600 micron sieve, balance, moisture content bins, glass plate, metal tray, scraper tool. Theory and application: determination of field density of cohesion-less soil is not possible by core cutter method, because it is not possible to obtain a core sample. In such situation, the sand replacement method is employed to determine the unit weight. In sand replacement method, a small cylindrical pit is excavated and the weight of the soil excavated from the pit is measured. Sand whose density is known is filled into the pit. By measuring the weight of sand required to fill the pit and knowing its density, the volume of pit is calculated. Knowing the weight of soil excavated from the pit and the volume of pit, the density of soil is calculated. Therefore, in this experiment there are two stages, namely: calibration of sand density, measurement of soil density.
Procedure: calibration of sand density. Measure the internal dimensions of the calibrating can and find its internal volume of calibrating container, V. Fill the sand pouring cylinder with sand with 1 cm clearance at the top and find the weight, W1. Keep the sand pouring cylinder over the calibrating cylinder, open the shutter and allow the sand to run out in the calibrating cylinder until it filled. Now determine the weight, W2. Place the sand pouring cylinder on the glass plate, open the shutter and collect the sand on the glass plate and wait for at least 3 times, W3. Weight of sand to fill calibrating container, WC equal to, W1 minus W2, minus W3, G. Bulk density of the sand equal WC divided by V.
For the calibration of unit weight of sand, the following data is noted in minimum 3 trails as shown.
Measurement of soil density. Clean and level the ground surface where the field density is to be determined. Place the tray with a central hole over the portion of the soil to be tested. Excavate a pit into the ground, through the hole in the plate, approximately 12 cm deep, same as the height of the calibrating can. The hole in the tray will guide the diameter of the pit to be made in the ground. Collect the excavated soil into the tray and weigh the soil, W. Determine the moisture content of the excavated soil. Place the SPC, with sand having the latest weight of W1, over the pit so that the base of the cylinder covers the pit concentrically. Open the slit of the SPC and allow the sand to run into the pit freely, till there is no downward movement of sand level in the SPC, and then close the slit. Find the weight of the SPC with the remaining sand, W4.
Field density is calculated by the following tabular column.
Thank you for your time. If you have any queries, do not hesitate to contact us.